Estimating rebars on beams and columns is done through direct counting. Watch this video for an example here in quantity surveying. The beam for the study contains two segments, which are designated as beam 1 and 2. They are supported by 400 by 400 columns. A partial list of the beam schedule is also specified, where both beams are of 400 by 500 mm size. Top bars for beam 1 are written as 5, 2, and 4. Then bottom bars are 3, 8, 2. The top bars on beam 2 are 6, 2, and 3. Then the bottom bars are 2, 6, and 2. Before estimating, illustrate the beam rebars to interpret how the layout looks like in each beam. Starting from the top bars, check that beam 1 has a minimum number of 2D20. This is also the same when looking at beam 2. The minimum number of top bars is 2, which means we can draw a continuous bar from beam 1 to beam 2 and designate this as 2D20. Next is to illustrate the cut bars, starting from the top left bars in beam 1, which shows 5D20 in the schedule. With two continuous bars, there are just 3 D20 cut bars remaining. Opposite the left support top bars, there are also the right support of beam 1, which shows 4 D20. This means there are 2 D20 cut bars as there are two continuous bars already. If we proceed to beam 2, there are 6 D20. So we can interpret this as another 4 D20 cut bars on top left support for beam 2. Refine the top bars as the two bars from beam 1 can go straight to the top bars in beam 2. So the remaining cut bars from beam 2 are 2 D20. The right top bars of beam 2 count to 3 D20. And with two continuous bars, there should still be one cut bar remaining. This completes the top bars on both beams. Now check the bottom bars. From all the numbers in the schedule, the least is 2D20. So draw a continuous bar from beam 1 to 2 and tag this with 2D20. Move on to the left support of the first beam. The bottom bars in the schedule show 3D20, which means there should be a cut bar at this location. For bottom midspan of beam 1, there should be 8D20, which asks for 6 cut bars in this location. However, remember that there is one D20 on the left, which means we can continue this bar until midspan. This then will make only 5 D20 on midspan with the midspan length. Next is then to lay out the bars on the bottom midspan of beam 2. There should be 6 D20, so with two continuous bars, there should be 4 D20 cut bars in the midspan. Check if the number of bars laid out is right in each location. For top bars, starting from the left, there are 2 continuous and 3 cut bars, which account to 5 D20. At midspan, there are just 2 D20. And at the right support, there are 2 continuous bars and 2 semi-continuous, which would equal to 4 D20. For the bottom bars, the left support shows 2 continuous with 1 cut bar, which become 3D20. At midspan, there are 2 continuous, 1 semi-continuous, and 5 cut bars. Those are equal to 8D20 at midspan. Then at the right support, there are just the continuous bars, 2D20. For beam 2 top bars, the left support carries 2 continuous, 2 semi-continuous, and 2 cut bars, which equal to 6D20. Top midspan has only 2D20. Then the right support contains 2 continuous and 1 cut bar, which equal to 3D20. For the bottom bars, bars at the left support are mainly the continuous bars, 2D20. At midspan, there are 2 continuous and 4 cut bars, which equal to 6D20. From the right support, there are only the continuous bars, 2D20. With quantities already determined, the next thing to do is to figure out the lengths. From ACI 318-14, the top support's length is a third of the clear span. For the beams of 3 meters clear span, the length on top supports are computed as a third of 3 meters, which is 1 meter. For the bottom midspans, the length is taken as 3/4 of the clear span, that is 3/4 of 3 meters, which turns as 2.25 meters. With these standards, start computing the individual lengths. The continuous bars have length of the summation of 2 clear spans plus the width of the middle column, then add the development lengths of both ends. The development length is 50D, so the total length becomes 3,000 plus another 3 meters, then the column width of 400 plus twice of 50D, or 2 times 50 times 20 mm. This results to 8,400 mm or 8.4 meters. Thus, top bars are 2D20 of 8.4 meters length. And this is true with the bottom bars too. Now solve for the lengths of the cut bars. For beam 1, the left top bar has a length of a third of the clear span plus the development length. This is like 1,000 mm plus 50 times 20, which becomes 2,000 millimeters. So there are 3D20 of 2 meters on the left support. For the right top support, the length is a third of 3 meters plus the width of the column with another third of the clear span from beam 2. That is taken as 1,000 mm plus 400 with another 1,000, which equals to 2,400 mm. The estimate then becomes 3D20 mm by 2.4 meters. For the bottom bars in beam 1, there is 1D20 at the bottom left support, and this continues until the midspan. To calculate the length, note that the midspan is 3/4, so the remaining length is 1/4, and this will be divided between the left and right supports. So if the right support is 0.25 over 2, the length of the bottom bar is then 3 meters minus 0.25 of 3 over 2, then add the development length. L is then 3,000 plus 375 plus 50 times diameter 20, and it gives 4,375 mm. Then the left bottom bar is then 1D20 mm by 4.375 meters. For the mid-span bar, the length is 3/4 of 3 meters, which is then 2,250 millimeters. That completes the specification of 5 D20 bars by 2.25 meters. Next are the cut bars lengths in beam 2. For the left top bar, the length is 1/3 of 3 meters plus the development length. L is then 1,000 plus 50 times 20, which is 2,000 mm. The bars are then 2 D20 mm by 2 meters. The right top bar has a length similar with the left support, so L is then 1,000 plus 50 times 20, which is another 2,000 mm. The right top bar is then specified as 1 D20 by 2 meters. Last is the bottom mid-span cut bar in beam 2. The length is then 3/4 of 3 meters, which equals to 2,250 mm. The mid-span then has 4 D20 mm of 2.25 meters. The main beam reinforcement are then summarized as follows. The continuous bars are 2 D20 mm by 8.4 meters length for top and bottom bars. In beam 1, the left top bar is 3 D20 mm by 2 meters. The right top bar is another 3 D20 mm but 2.4 meters. The left bottom bar is 1 D20 by 4.375 meters. And the bottom midspan is 5 D20 mm by 2.25 meters. For beam 2, the left top bar is 2 D20 by 2 meters, with the right top bar as 1 D20 by 2.4 meters. The bottom midspan is 4 D20 mm by 2.25 meters. So add quantities of those bars with the same lengths. So the final cutting list contains 4 diameter 20 by 8.4 meters. Also 1 D20 by 4.375 meters. Next are 4 D20 by 2.4 meters and 9 D20 by 2.25. There is also 5 diameter 20 by 2 meters.